Good evening, everyone. Let's try that one more time. Good evening, everyone. Yes, there we go. There we go. Welcome to Southern Solutions, Plant Science as an Economic Engine. My name's Neil Lamb, and I have the pleasure of serving as your MC tonight. We have a terrific evening ahead as we dig into how plant science and innovative agricultural practices are reshaping the South, creating new manufacturing pathways, and helping revitalize local communities, especially rural communities. Before we begin, I'd like to acknowledge the sponsors whose generous support have made today's events possible. First, I want to say thanks to J.P. Morgan Chase for sponsoring a stakeholder gathering earlier this afternoon. Thank you all. Thank you very much. And a special word of thanks to the ECTA Foundation, tonight's presenting sponsor. ECTA's founders, Ashok and Amrita Mahbubani, have been steadfast supporters of HudsonAlpha across all of our mission areas, and especially in the NSF engines that we'll talk more about later tonight. They're advocates, encouragers, partners, and friends. It's a pleasure to invite Ashok to the podium to say a few words. Ashok.
Thank you, Neil, for that very gracious and kind introduction. And let's do it a third time. Good evening, everyone. This event was placed on the calendar months ago, and we couldn't possibly have known the context in which we would gather here today. That certainly has changed. HudsonAlpha's BRIDGES is an NSF Engines Award recipient, and the consortium will receive $15 million in year one, with the prospect of performance-based annual funding at the same or a higher level for 9 more years. That makes BRIDGES the single most impactful philanthropic investment that the ECTA Foundation and our family, 3 generations represented here today, has ever made. Why did we do it? We liked the clarity of direction and purpose. We would transform perennial grasses into fiber and byproducts for use in automotive components, close to our heart, construction materials, and packaging. We heard that first in 2023, and it's still the plan. Second, we were intrigued by the idea of a nonprofit like ours joining hands with others to create a for-profit, self-sustaining economic engine. And third, a consortium partner in Tennessee was running an integrated manufacturing plant using grass from 9,000 acres of farmland to produce over 2 billion units with a B of packaging. BRIDGES will build and improve on this proven real-world model with farming, plant genomics, material science, logistics, and manufacturing, reimagined to produce high-quality biodegradable or compostable products at scale for a competitive commercial marketplace. We will take from the earth, and when a product completes its life, return what is left to the earth in a regenerative, planet-friendly cycle. For the people in our rural heartland who will play an active role in making all this happen, the circular economy I just described is in fact a circle of life and livelihood. the human dimension of bridges. We're confident that this will inspire the stellar Bridges team from across our region, backed up by HudsonAlpha and every member of this consortium, to work together on making the promise of this program a reality. May the force be with them and within them, always on this journey. Thank you.
Thank you, Ashok, and thank you also to the ECTA Foundation. Now, many of you have probably seen the recent announcement that HudsonAlpha has been awarded an NSF Engines grant. You just heard Ashok do a wonderful job of highlighting what that is about. I'm going to take a couple of minutes to explain a little bit more about what the Engines does, what our project does, and why we feel like it is truly transformational. So, slides, please. Do I need to go ahead and click this one forward? Click it forward. Thank you very much. All right. So HudsonAlpha's NSF engine is called BRIDGES. And as you can see, nope, I want to go backwards. BRIDGES stands for Bio-Based Rural Innovation for Domestic Growth and Economic Security. That's a mouthful, so we just call it BRIDGES. Let's walk through that just a little bit. So the National Science Foundation began the Engines initiative specifically to boost innovation, and not just individual types of innovation, but to set out a regional sustainable innovation ecosystem. So an ongoing process of innovating and moving forward that demonstrates clear economic growth. So the innovative ideas and tools and technologies have to lead to something that is useful, that is productive. And ultimately, that means that we're building out regional solutions that have long-term economic and societal impacts. So it creates products that markets want. It creates jobs. It upskills jobs. It creates opportunities for students. In our instance, it also creates opportunity for farmers. And as Ashok said, I'll make a slight modification. It's $15 million split over the first 2 years. And then if we meet our metrics, then they open up other dollars year after year. So there are some expectations on our end as well. But $160 million over 10 years. Now, our area of service, BRIDGES, is a 2-state program with a number of counties in Alabama and a number of counties across Tennessee. HudsonAlpha serves as the hub, but we also are anchored on each end by 2 key universities. The University of Tennessee at Knoxville and Auburn University are key partners here, along with a number of other players. I'll show you in just a minute a list of all the partners at the table, and it is truly spectacular, the number of people that are a part of this. The focus area is on agriculture and advanced manufacturing and the intersection of those two. So specifically, how we actually can create bio-based products, plant-based products, again, from tall grasses like miscanthus and switchgrass, and turn those plant fibers, that plant material, into products in the automotive industry, like part of the car door that you see over there, or packaging, like you see on this Adirondack chair over here, or construction materials. This is the raw material. So this is one of the perennial grasses. Miscanthus, this particular variety, grows up to 14 feet high. And again, the idea is you take that plant material, those stalks, those leaves, and you can shred them, and then you can create these products in packaging, automotive, and in construction. And ultimately, that benefits a whole set of individuals. It benefits farmers because now you can grow these grasses on marginal land. So it is another thing that they can grow on land that they currently aren't growing any kind of crop on. So it's an additional source of income for them. Over time, it actually restores fertility to the earth. So there's a benefit back there. It benefits the next generation of workers because we're bringing high-tech automated manufacturing into these rural communities where these grasses are being grown. So you are offering opportunities for students, you're offering abilities to upskill for existing workers, and this is especially true in our rural communities, in our rural farming communities, and then you're creating investment opportunities as you grow the market for these materials, as you build partnerships with construction groups, with automobile manufacturers, with other packaging teams. You are now creating opportunities to move that innovation forward, and investment flows into the community. So let's now dive just a little bit into a tiny bit of science. Let's come back to these plants. How do we actually get from these plants to these materials? Well, you can take the fiber, the fibrils of the plant, which you see on the left-hand side. These are the miscanthus fibers. You can integrate that in, whether that's packaging, whether that is cement, whether that is molded injectable pieces, and it provides additional stability and strength, but it is also biodegradable and recyclable over time. You can also take some of these components of these grasses and you can turn them into foam. So that's valuable for foam packaging. That's valuable for insulation in homes. You can also take some of these materials and you can turn them into oils, into coatings that actually provide protection. Maybe that's over wood, providing protection against the elements or other types of coating. So from one single section of grass, you can create so many of these biological-based products. Now, in order to get the specific kind of product that each market needs, so one market may need something with a higher level of a certain lignin or a certain cellulose or hemicellulose. One may need a certain fiber length. Every one of these kinds of grasses is not going to be optimized. So you're going to have to go through and develop different varieties of these grasses, each with the specific qualities that the market individually needs. And that requires an understanding of the impact of the genetics that leads to the specific varieties and being able to develop and breed rapidly the kinds of plants that you need. And that's where the expertise of HudsonAlpha comes into play, especially in the labs of Jeremy Smuts and Jane Grimwood and Kangshita Swaminathan. And let me just pause because several of those folks are here. Many of them are lined up along the back, but others, if you guys are a part of this team, would you just wave your hand for just a second? Everybody turn around and look. These are the HudsonAlpha experts, yes. They're the folks that are moving us from the DNA to the plant to the specific varieties. And then HudsonAlpha is also the hub site. So Sam is leading and herding all of the groups, all the partners moving together. We're actually working with our economic development team and innovation and entrepreneurship, and with our education team as we think about educational materials that go in classrooms and helping with workforce development. So this is the list of partners. It is a massive list of partners. The closer you move into the center, the more they are involved in the day-to-day operations of the engine. But it is some really powerful, really impactful groups, not only across the South, but that have a global reach. So what happens now? We received the notice about a month ago that we got the award. So we've been very busy. What happens over the next few months? Well, we've got to build out the governance structure. We've already done a lot of work on that. We've got to hire the positions into these operational roles to build this out. We're working on finalizing the evaluation criteria and the metrics that we will present to the National Science Foundation, and then launching the R&D pipelines, the commercialization pipeline, and the workforce development pipelines. So we're going to be incredibly busy over the next several, I was going to say months, but really over the next several years, ideally over the next decade, as we move this initiative forward to truly transform across Alabama and Tennessee this economy around using bio-based, plant-based materials. You'll hear us talk tonight about bio-based. That's a plant-based approach. You'll hear us talk about feed stocks or fuel stocks. That is the specific plants that we are breaking down into the materials. You'll hear us talk about circular economy. That's the fact that we, as Ashok said, we grow something from the earth, we integrate it in, and then when it is finished the end of its life cycle, it returns back. It's compostable, biodegradable. So that was the rapid overview. of the BRIDGES initiative. And Sam, feel free to jump in at any point when the microphone is yours and make any kind of corrections around that. But without further ado, let me now hand the microphone over to Dr. Sam Jackson, who is with HudsonAlpha, who is leading the BRIDGES initiative, because he's going to introduce our keynote speaker. And so, Sam, come on up. As Sam's coming up, I want to tell you, Sam's a scientist, an entrepreneur, and a champion for plant-based innovation. We are incredibly blessed to have him here at HudsonAlpha. And before he joined HudsonAlpha, he spent over 2 decades working in sustainable biomass, so crop production for plants, and bioproduce, so bioproducts. So he knows what he is talking about. Sam.
So it's definitely an exciting time for us, and I was telling some folks earlier, I feel like I've been underwater for that month since this announcement came out, because there's a lot to do right now. But it's a transformative opportunity for all of us involved and for the regions for sure. And so tonight, we've put together a keynote speaker and some panelists that I hope that when you leave here this evening, you are literally saying to yourself, I've never thought about that. I didn't know that was possible. I didn't know that tied into the circular bioeconomy that we're all trying to get to. And so as we launch into the engine, and as we go over the next decade in this work, the possibilities are literally unlimited at this point. There are so many things that we can do. And so tonight, I'm pleased to get to introduce our keynote speaker, Dr. Zara Summers. She serves as the Chief Strategy Officer at LanzaTech. And I can tell you that LanzaTech is, and she's going to give you a great overview, is one of those shining stars of success. When I started in this path about 25 years ago, it was very focused on cellulosic ethanol and some of the technology at that point. LanzaTech was founded at that point, and they have grown and evolved over time, and it's a really great success story in how constant innovation, constant partnerships can create global success in a company. And so Zara leads the company's efforts to drive commercial growth, secure strategic investments, and unlock new value through business innovation, really focused on aligning market strategy with global demand. Everything has to work on an economic basis. LanzaTech is currently really focused on carbon recycling solutions, and you're going to learn more about this tonight. So in previous roles, she served as a chief science officer, so she's a scientist by background, overseeing the company's research and development pipeline and supporting operations across 6, but now 7 commercial plants, I understand, this evening worldwide. Prior to joining LanzaTech, she spent about a decade with ExxonMobil in their scientific and leadership group, focused on biological innovations for energy transformation and transition. She holds a PhD in microbiology from the University of Massachusetts and had worked on her postdoc at the University of Minnesota. She's described her career as being driven by a passion for enhancing economic, environmental, and climate stability through innovation and collaboration. I think that's a tagline that we may want to steal for the engine as we go forward, because that really encapsulates a lot of it. So Dr. Summers, podium is yours. Thank you.
All right. Well, I just want to say thank you for inviting me to this event. When LanzaTech started 20 years ago, there was nothing like an engine to drive it. And so seeing the opportunity that exists for all of you here, it's really exciting. So I'm going to talk you through what LanzaTech has done in the last 20 years as kind of a, here's what, if you're stubborn as heck, what you can get done. Because I think, you call us a shining star. I would say we just don't give up. I'll talk you through about the 7 valleys of death, of growing a company, an industry, and I think it's been a really, really impressive journey. So I joined LanzaTech 5 years ago to help bring a little corporate to a New Zealand company that moved to the US and is trying to take over the world using waste carbon. But really it's about persistence and partnerships. And so I see a lot of that here today. There's confetti, fun. So we at LanzaTech started with a vision that for a century, so I of course came from ExxonMobil for 10 years. I know, as many of you do, that we live in an extractive society today, Whether that's good or bad, it's just a fact. We pull things out of the ground, we use what value, we generate value, and then we emit what is left over. But if you would imagine carbon in a different way, what we're doing today is emitting carbon. That carbon actually has intrinsic value. And so what I'm going to talk you through today is a high-level vision that we had 20 years ago and still have today. It's that every carbon is precious. Just because you've unlocked value that we called value 100 years ago doesn't mean it's done today. So we take emissions and we turn that into a new product, a second product, a fuel to fly you on your vacation, clothes you put on in the morning, things you use in your day-to-day. And we do that at a commercial scale today, and now we have 7 operating plants around the world. But the challenge, it wasn't finding carbon. Our feedstock is not miscanthus. It could be. I'll talk you through how we use miscanthus, how we can use all sorts of different types of feedstocks. But we really just need a lot of carbon in one single place, and we can turn it into products. When we talk about circular economy, it's considering the carbon itself as something that can be reused over and over and over, maybe for a similar thing, maybe for some completely new end use. So it's about capture. We tend to capture right today at point sources of emission. So imagine a steel mill that has a blast furnace that is pumping out hundreds of thousands of tons of carbon monoxide a year. We actually just pipe that right through our big reactor. Our reactors are filled with bacteria. Those bacteria eat these gases and convert that into ethanol. So that's our step 2. We take that ethanol and we can convert it. It is such a beautiful building block. That ethanol goes into fuels. It can go into marine fuel. We can turn it into jet fuel through an oligomerization process. We turn it into leggings with Lululemon and Athleta. We turn it into perfume with Gucci. I know this sounds crazy, but it's actually real. We make fleece to keep you warm in winter. We make running shoes to make you run faster, at least look good doing it. And then those products, so we have all these partnerships with brand because they also have that vision of when you're done with those running shoes, they don't need to go in a landfill. They can go in what we call a gasifier and get turned back into usable gas that our bacteria will happily eat and convert into new shoes. So it's not just one conversion, it's a vision of we have so much carbon in our atmosphere and on our Earth's surface today that we can make everything you need and everything future generations need from it today. We just have to, if you can do these 4 steps, you can have products for life and life of humanity. This is my one AI slide. It made this image for me. I think it's obligatory these days. It's the scale-up journey. You know, when I think about the engine and the promise and the opportunity in front of the group here tonight, I think about what it takes to scale up. And scale up is not a step. It's not one step. It's a series of questions that you ask yourself late at night while you cry into a beverage of your choice. It's in the lab, will this work? Is this crazy? It doesn't seem to defy laws of thermodynamics, so could it be possible? But then you put it in a pilot, and will it work for more than an hour, more than a day, more than a week, more than a month? Can you scale it up, put it outside? Can it integrate into a facility where it's going to be part of a process that's going to drive an industry? Because your first plant, will anyone pay me to build it? That's a big one. Can I not only prove that it works, can I prove to somebody with money that they want to invest in this because this has promise? And then you're not done yet because can it become an industry? Can you do it again and again and again? And these are the things that are in front of you today, and I'm here to tell you, you can survive all of these valleys of death. You just have to have persistence and really good partners. But you don't usually fail in the discovery stage. And so failures in the lab, I was a grad student at one point. I taught grad students at a later point. It's not those are welcome failures. It's my commercial plant had a foam out. It's what don't I know about moving things outside. Outside is big and scary. Outside has monkeys. I'll be honest with you, we actually ran into a problem. We had 4 commercial plants up and running. Our first plant in India had a variable we'd never seen before. It's called the macaque. Macaques are very curious creatures. They're also quite aggressive. Never look them in the eye. They will come after you. They fight with dogs. They fight with anything. We had ball valves. We had ball valves on our commercial plant. Ball valves that were sticking out about this far when they were open. We actually had to say, how much momentum can a baby monkey while swinging put on that ball valve and close it? They were closing valves by playing. It is something like, someone asked me, well, what don't I know? What's the thing? You don't know what you don't know. None of our models, none of our scale-up models, none of our risk assessments, nothing ever had monkeys in it. We now actually have a decision tree that actually has what are the most curious local macrofauna is in our decision tree now when we're looking at a site. So, just saying. I've learned that lesson. No one here needs to learn that. You get different valves. But as the questions change in this process and the questions that you don't know that are going to come up, I think it always comes back to, who solved the problem? One of our scientists back in the lab, because he went and actually measured different strengths of ball valves and provided that to the engineers, because you need people that are going to be hands-on. You need people that are going to go and try and solve a problem, no matter how ridiculous it sounds as I tell it to you tonight. So the valleys of death, this is a beautiful valley, but they're there, and you just got to say, all right, let's go, and you get that ball and you push it up the hill. Because what 20 years of work has done has shown us, we started with biology. And I have a PhD in microbiology. What I did study was unique metabolisms that shouldn't exist, but they do, metabolisms that are ancient, metabolisms that exist deep, deep underground. And so at LanzaTech, our biology that drives us is a naturally occurring organism that has the oldest metabolism on Earth. That unique biology we cultivated, we learned from, and then we integrated it as early as possible with the engineering that was going to surround it. You cannot have a commercial process and think that how it behaves in the laboratory is going to be how it behaves in a 750,000 liter reactor. That is, I looked it up, I said, what's a good analogy? It's 5,000 full bathtubs is what Google gave me. That's how big our reactors are. They run continuously. Imagine Budweiser. Budweiser runs continuously, meaning they fill a batch, they ferment it, they take the batch down. We actually run our biological process continuously. The reactor has gas go into it and ethanol come out of it for 90 days at a time. We clean it out and start over again. So we do 4 turnarounds a year. But we had to move on to engineering, we had to integrate modeling, and we had to learn from real feedstocks. Our feedstocks are steel mill off gases. Our feedstocks are municipal solid waste that we turn into syngas through a process called gasification. We've done over 20 different types of biomass, including miscanthus. We've also had to teach people about what we do. Our biggest competitor in my field is people not doing anything with their emissions and just throwing away beautiful carbon. That's my biggest competition today, because there's so much carbon in the world that all of you could go out and start companies and we would still not compete because there's so much out there, right? And so we had to create markets, we had to create customers, we had to show that products feel the same And we had to create new business models to make this scale. But this, as you pick all of these things up, as you learn all of these things, it makes every next problem you're going to solve go faster. And that's one lesson we have learned, is that every plant, there's gonna be a challenge. Every commercial deployment, there's gonna be a new challenge. Every time you're gonna get faster at solving the problems. I mentioned to you we have an organism inside our reactor that is the oldest metabolism on Earth. Okay, this is where I go into professor mode, bear with me. Imagine the world 3.6 billion years ago. We are no longer being bombarded by asteroids, so we have very little magma flowing on the surface. Liquid water has formed, bonus. We are covered in reduced gases, that is, no oxygen, that's like 200 million years from now, right? So we have hydrogen, carbon monoxide, and carbon dioxide. That's what my organism eats. That's why we can eat industrial emissions. So this organism has the oldest still existing metabolism on Earth. It is used to early primordial Earth. And so it is happy if you take emissions from heavy industry and just pummel it. That's what it eats. That's what makes it happy. Good on it, man. But we didn't have to fix the biology. We had to understand how to make the engineering and the world we create for it ideal for it. We didn't have to, nature had, I mean, I can't compete with 3.6 billion years ago. I've had arguments with AI folks lately. They said, well, we could come up with a better metabolism. And I'm like, I get that AI, I mean, there are so many things we can do, but 3.6 million years of natural selection is a pretty powerful tool. So we harness this organism, and what we've learned from it is, man, is it flexible. It can eat anything you throw at it. It takes these gases in any conformation. It can take contaminants like sulfur and other things and actually use it. It actually grows faster when you give it sulfur. And so what our organism, what we learned from it, is that flexibility is possible when you sit back and think, where do these gases exist? And so we have, when we talk about feedstock, we talk about anything that's carbon containing that can be turned into a gas or is a gas. If it has those three gases, carbon monoxide, carbon dioxide, and hydrogen. So we take blast furnace gas from steel, we take ferroalloy off gas, we work in a refinery. We take off gas from units around the refinery. We have projects in India that are focused on sugarcane bagasse gasification. We're turning that into gas. We take forestry waste. We take plastic waste, unsorted plastic waste. We can turn back into hydrocarbons, CO2 and hydrogen. We've done over 25 different biomass waste streams. We've done municipal solid waste, which is a story I'll tell you about. We've even taken methane from landfills and from anaerobic digesters, done a partial oxidation and fed that into our process. And we've done direct CO2 plus hydrogen fermentations as well. So why we care about this feedstock flexibility is that we really wanted a global solution, and we wanted to be able to provide solutions to nations that maybe don't have what you would consider natural resources today. The fact of the matter is, if there's people, there's garbage, and we can use garbage. If there's heavy industry, that could be seen as somewhere that no one wants to live. We put our plants onto these heavy industry. Not only are we taking the emissions and making something valuable out of it, we're actually removing particulates from the air, and we're cleaning up local air quality as well. And so there's a lot that we can bring to places where traditionally maybe would not have been somewhere people wanted to live, or would not have been someplace that would consider having a natural resource. Because we leverage waste carbon, it exists everywhere. So our process is we take our different feedstocks, any of those, we can mix them together too. They go through the reactor. The microbes are used to fluctuating environments. They're They're a wild microbe. They're not a lab microbe. They're a wild microbe. And what we've done is made a reactor where they're happy. And so if you have higher carbon monoxide one day to the next, they'll still grow and make ethanol. Our products are ethanol and the microbe itself. The ethanol today we sell into the fuel market and the chemical markets. The microbe itself, about 95% of our carbon comes out as ethanol, 5% comes out as the bacteria. The bacteria we sell today into the aquaculture market. We have a higher, so what we compete there with is the soybean meal market. We have a higher protein ratio, a better amino acid slate, and make happier, fatter fish. So we sell into the aqua feed market there. So at no part are we wasting any of the carbon, it's all going to product. But where we're at today and where we grew, I think I've mentioned partnerships a few times. We've worked with academia, and this is where we did a lot of the initial tests when we were first starting out. Understanding the fundamentals helps you understand how to engineer a system. We worked with industry, building it at a commercial site. You need to understand all of the fluctuations that could be coming at you because of where you're at these commercial sites. We've worked with brands, so these are some of the products we've made. We really, really have used our brands, not from a lot of our ethanol goes into the fuel market that you'll never hear about. Very small fraction goes to these types of products because we make so much ethanol. But what they do is they help us tell the story. They help us tell the story to people like you, to people that come to a store that pick up a thing and say, oh, what's recycled CO2 mean? These brands have helped us with the storytelling because I think people need to start to connect. It's like the question of if you ask an American, they say, walk down the street of New York City and ask people where does electricity come from? And over 50% of the people will say the wall, right? And that's just right, because your world is your world and where you exist and what you think about is just what you see. And the electricity for many of us comes from the wall. You don't think about, well, what's your sourcing, what's your load, why would you do something at night versus during the day? What's that have to do on your carbon footprint? That's not what this talk is about. I encourage you to go look at your loads. But for us, it's where does your carbon come from? It's a good question to remember later. We partner with government. I mean, this NSF engine is a great example of strong government support and partnership, but we have worked with legislators in Europe to get recycled carbon fuels actually listed when mandates come out and alternatives to fossil have to be served, you need to get your solution in there because unfortunately the truth of the matter is policy is not always outcome driven. Sometimes it is process driven. And when they have policy that will be process driven, it kind of kills innovation because it's saying if it's outcome driven, that leaves rooms for many paths to that outcome, to that end point. Whereas when it's process-driven, it's very prescriptive of how you get to that end point. And so what we have done as a company is help people see there's more than one way to get to a goal and making sure that policy reflects that and enables innovation for all companies. And then, of course, capital, helping people understand why it's a good investment. You have to have a bankable project. Your first plant is very important. It's your least economically attractive plant, so you need to find someone that's willing to take that journey with you and go on the vision of it will get better, here's why we think so. But really, I think, and I mentioned this, a very small fraction of our product actually goes into the hands of consumers, but it makes it real. It's really important to see the product, right? This is connecting it. So for us, these are just some of the brands we've worked with. So you can go online, buy a Craig Hopper fleece jacket made from recycled carbon. That these are emissions that were coming out of his steel mill that are now in a jacket instead of the atmosphere. We have Where My Heart Beats perfume with Gucci. We have L'Oreal shampoo bottles we've worked with. There's laundry detergent you can buy in Germany and Austria. We have a bunch of cleaning products there. We've done many partnerships with shoes and athletic clothing. So we have Lululemon, Athleta. This is On Running. You can maybe see that it says made from carbon emissions on that shoe. And then of course we have our jet fuel. So that's the Orlando to Heathrow flight that Sir Richard Branson and our CEO Jennifer Holmgren took. So that was on 50% of that jet fuel was ethanol made from emissions. So very, very exciting flight. But it's important to connect to people, even if it's not going to be your largest market, because if people understand it, you have advocates out in the wild. And from a partnership perspective, you know, we've done a lot of partnerships with numerous institutions at universities, at national labs. They help with the discovery phase. Thinking you can be a one-stop R&D shop is crazy and very expensive. You will ultimately need some piece of equipment that would cost you so much money to buy. If you just partnered with a university, you would get enthusiastic grad students that want to work with somebody who can show them a real application. And so we've done that, and we continue to do that. We have interns every year, and I have employees that are 10, 12 years with the company that started as interns. It's great from workforce development. It's great from just energy perspective. We have industrial hosts. We sit at the nexus of two very different industries. I have heavy emissions, people with steel and refineries, and then I have consumer brands. And connecting those two is not usual, but we do, and that's kind of where we sit. So we have market partners that drive the demand, that make it real. When I can give someone a pair of shoes made from industrial emissions and say you should invest, it's different. It hits different when you can see that full circle, when you can see that product in the hand. But all of this is to say that you will continuously, as you grow a company and grow an industry, which is what you're doing, you need to evolve with the risks as they come. Your initial risks are going to be different than your later risks, and it's all about risk management. It's what don't I know, and how am I going to get in front of it so we can keep moving forward. If you want to lay down in one of the valleys and cry, that's fine, but get up and get on with it eventually, because the easy thing to do is give up. But if you have strong partnerships, they drag you out of there. And so having people that are world-class, world-scale industrial partners does help, but also having the academics that don't know enough to not be crushed by the world yet. So you need both. You need both. You need the dreamers and the realists, and you need them to both be at the table with you, because you never know what the next problem is going to be. So a little bit of just a quick aside. This was our trash to fuel project. This is unsorted municipal solid waste. If you look at, there's 3 pictures at the bottom. The first picture is what we call the pit. The pit is garbage. The pit is garbage from a large city in Japan. It picks up whatever the trucks have in the dumpsters and dumps it in the pit. The claw works in the pit. The claw grabs whatever is in the pit and puts it in the gasifier. One day it's construction waste. One day it's waste from homes. The other day it's market waste. One day we were there when an entire load of rotted sea cucumbers came in. It was the worst day of my life. Ugh. Whatever it is, it gets picked up by the claw and it goes in the machine. Imagine planning for, you were talking about the different breeds of miscanthus and you want to make sure they're right. Imagine having no control over what goes in. You just get the gas out of the back end. That's what we were doing in Japan. No one thought we could do it. We did it. We did it so well that we completed 8 years of a pilot where we would just test that gas every day. The gas would fluctuate wildly. We would produce ethanol at a constant rate on the back end. So then we were so lucky we got the 1/10 commercial plant announced in 2020. Building a first-of-a-kind plant during a global pandemic is a 0 out of 5 stars. But we did it anyway, because you don't give up, you pick yourself up, and you just keep working. And so we built our 1/10 commercial plant, which is a massive plant next to a massive collection facility. But this, if anything, this project was persistence. We could have given up at many, many points because the gas was really complicated. The toxins that would get through to our bacteria, we figured out an entirely new way to clean gas so that it didn't harm our living bacteria. On the back end, we learned how to do construction in a global pandemic. We had a couple other plants being built at the same time. And we figured it out. We figured it out because we did not accept that having it not become a reality, it just wasn't possible. And so there is something to be said. I know that we are well known in the industry for being persistent and for still being here, and that's because we just don't stop. And so just don't stop. And so these are our 7 commercial plants, although I don't have a picture of our newest one. Our first commercial plant was in China. We actually started building the plant in Belgium before we started building the plant in China, and then we had 5 plants in China almost before we had our Belgium plant. It's just different in different parts of the world, right? You learn and you adapt. We have our plant in India, in Panipat, in Haryana, in northern India. All of these are using slightly different gases, but all of them are producing ethanol, and all of them have the same microbe inside. And so it's really like amazing to sit here when I get to give talks like this and you reflect. Your day-to-day is in the valley a lot. And so to think about all that we've done is really exciting. And not only have we done these things, we've gotten so many certifications proving that our ethanol is 1/2 to 1/10 of the carbon intensity of corn ethanol. So because we are recycling carbon and because we are being as efficient and cost effective as possible, we can do things that nobody on earth can do. We have such low carbon intensity products that our customers come to us so that they can offset their footprint and achieve their net zero goals. And we're still working at becoming an industry, but that's the goal. So it's not just the first commercial plant, it's not the 7th commercial plant, it's becoming a full industry that's globally recognized. And so there's always a goal. You just keep moving it once you achieve something. So this is our plant in Belgium. I'm gonna play look, it worked. So those 4 elephants you see over there, the big white ones, those are our 4 bioreactors. Next to that on the left is our distillation where we purify the ethanol. These little short white things in front of the bioreactors, that's our gas treatment. And so this is outside of Ghent. Very beautiful, nice city, beautiful castle if you ever want to visit. So this is our commercial plant in Europe that is providing low carbon fuels to pretty much anyone in Europe that needs them. So it was a big accomplishment. But I think one other thing that we've learned as a company is it's not just enough to build, it's a spin-out world as well. And so there are some ideas that we incubate and grow in our company that when they get to a point, we actually decide to let them go. It is important to retain and remain focused as a company. So we've spun out LanzaJet. We have LanzaX, which is partnering with the European universities. And then we have the LanzaTech nutritional protein. LanzaJet is focused on alcohol to jet. It's a very good complement to us. We make ethanol. They take ethanol and turn it into jet fuel. LanzaX creates new strains from our unique microbe that makes different products. And then LanzaTech nutritional protein that is using our hardware, using our bioreactors to make on-demand protein. So I told you today, 5% of our carbon ends up in protein we sell into aquaculture. We imagine a world where it's going to get really hard to feed all the people on the planet. So we have a solution for that as well, where we take the same reactors and we just grow biomass and we make nutritious food for aquaculture and other things. So with that, I'd like to thank you for your attention and going on the journey with me. And I just see so much promise in front of you and this group and HudsonAlpha and others and this BRIDGES engine. So I can't wait to come to a talk and see all you've done in a few years. So thank you all.
Dr. Summers, thank you for sharing. That was like a master class in inspiration, persistence, the valleys of death. That was wonderful. Thank you. All right, so let's invite the rest of our panelists up so we can have a panel conversation. So let's begin with Derek Saltzman. Derek is the CEO and co-founder of Soarce, which is a materials science company developing sustainable bio-based materials for manufacturers that are looking to reduce their environmental footprint. Interestingly, Derek and his co-founder met as freshman roommates at the University of Central Florida studying aerospace engineering. So you never know what you're going to find with your roommates. They first launched a company making carbon fiber drone parts before pivoting into materials science. And then let's bring up Rob Tripp. And Rob is the founder and the CEO of Poulterra, which is a company that's building a circular, nature-based platform to improve sustainability in poultry production. We know something about poultry here in the state of Alabama. Their goal is to make poultry the nation's lowest cost, lowest carbon animal protein. Previously, Rob co-founded Benefuel, where he developed and scaled a catalyst and process to convert waste materials into biodiesel and bio-based lubricants. He's also led the scale-up of a wood shavings packaging business that serves the poultry industry and co-founded a software company. And then Sam Jackson, who I introduced earlier this evening, who leads the BRIDGES engine at HudsonAlpha. So let me actually come over and sit in a chair as well, and then let's get our panel conversation started. Okay, all right. Okay, panelists, thank you for joining us. Let's start with a foundational question to maybe ground the rest of our conversation. Why are we focusing on plant-based products? What do they offer that is so attractive? And this is open to anybody. Why plants?
So I'm not known for being quiet, so I'll start. So I think plants represent a great opportunity to cross a bridge between agriculture and industry. And so we're living at a time in the U.S. in particular where a lot of our farmers are struggling. Even when they're producing some of our more valuable row crops, they're under a lot of pressure globally from prices, from input costs and things like that. And so I had some conversations last week in Dothan with some of the largest farmers down there. And at best, the best farmers will break even this year. And so the more we can do to create new markets for those plant-based products, whether they're based on corn or switchgrass or miscanthus or wheat, we need to do that to ensure that we have the capacity to produce food for future generations and to keep those farms in green spaces. So creating that value at the farm side is something that's really important to me personally and to the BRIDGES engine. But I would also say that the more we can grow and then manufacture our own products here in the US, domestically, locally, it just creates that much more value in those communities as we think about where that dollar circulates as it goes from farm to the manufacturing, to the distribution, to the use and the reuse and those kinds of things. And so as we think about how we can create economic development in our rural communities, I think it automatically goes to plants.
And I would completely agree with that in the sense that I think plants and natural feedstocks are kind of the feedstock of the future. We're at our team, we're a big Marvel fan. We kind of, everyone's got their own superhero. So if anybody has seen the movie Black Panther, Wakanda, if you've seen that, I mean, they turn plants into spaceships. And that's kind of the ethos that we believe in. And to Sam's point, I do think that they can be not only feedstocks that are grown here, manufactured here, but actually have really high performance properties that we have not been able to unlock just yet. And that goes to what you were speaking to earlier, where plants got not 3.4 billion, maybe 3.2 billion years of development.
Okay, so anybody else want to jump in on that, on why plants?
I mean, from our perspective, it's the cheapest direct air capture you'll find. So if we want to grab carbon that's just floating in the atmosphere waiting to be used, plants are our vessel to do that. And that's why we like them as a feedstock as well. So
Plants are kind of superheroes.
they are.
Although it sounds like your bacteria is pretty
mean,
superhero as well.
They're like the Padawan learner, to go back to.
There we go.
Okay, so along those lines, help us understand what kind of products can be developed from plants. I mean, we've talked about door panels, we've talked about packaging, but tell us, I'd like each of you to tell us about something that's happening right now and then something that excites you that you see coming down the pike.
Well, I think for my business, we're using miscanthus grass as a substitute product for poultry. Today, poultry, the industry uses a lot of wood-based products for bedding down chickens, turkeys, and the supply and the price of any wood-based product is really hard to determine. It's a byproduct from a lumber mill. So the nice thing with miscanthus, it's a perennial grass. You can plant it once. You know what it's going to cost. You can lease land to grow it over a long-term basis. It becomes predictable and something that you know is going to be available. So for us, it's a way to improve a supply chain.
And then for us, I mean, some of the products that we're currently making, so to kind of give a little background on what our company Soarce does, we consider ourselves kind of the modern day refinery, where we're essentially taking a variety of natural feedstocks, miscanthus being the main one, and being able to refine that into a variety of different grades of products. And one of those is, I have kind of 3 little vials on me. We're like the watch salesman, we'll bring everything with us. But these are 3 different products essentially here. This is a fractionated material from the miscanthus. It's a lignin-containing material, so really great for oil barrier, grease barrier applications for packaging. We've noticed that has some antioxidant and UV properties for potentially cosmetics. Another version, which has been really, really interesting for us, and what my co-founder and I's background is really focused in on, is nanocellulose. So as you described earlier, we can break those macro fibers down into smaller and smaller and smaller fibers. Well, inside of here is a fiber that is 10,000 times thinner than a human hair and 8 times stronger than steel. So, like, I really want people to wrap your heads around that plants really do have the capability to enable some really great manufacturing capabilities.
Will you say that again? It's about the hair and the steel one more time?
It's 10,000 times thinner than a human hair and 8 times stronger than steel. And if you don't believe me, I got photos I could show you. I could show you an AFM microscope photo of it compared to your hair. But we're utilizing this technology today in a lot of advanced manufacturing for aviation, so composite structures for marine, so traditional things you might come into contact on a daily basis, fiberglass, carbon fiber, Kevlar, things that you come in contact and don't even really know you come in contact with on a daily basis. And the final product, which is, I could say is...
I found this on the web, but a lot of manufacturers
Well,
traditional...
even AI thinks it's a really good idea. And this is kind of one of the final pieces that we're looking at here, which is high purity cellulose, which is actually a great input for my background and my co-founder's background when we did a lot of work in aerospace and aeronautics. Is a lot of those systems are utilized, actually cellulose is used as a precursor to ablative material. So think of re-entry vehicles for NASA, as well as kind of the current situation that's going on. A lot of the chat about the defense industry is how do we manufacture products here in the States? How do we keep supply chains here in the States? And that's one really big area that we're focusing on now, where we just want a really strong, big DOW contract on basically turning miscanthus into one of the new inputs for the American munitions programs. And that is a really big pain point for supply chain and a variety of the current, I would say, geopolitical things going on around the world.
I really do feel like we've just stumbled into like superhero land here with all this information. So I was gonna, now that we've talked a little bit about why plants, let's talk a little bit more about your organizations. And Derek, you've just given us a great overview of Soarce and of the key things that you're working on. So I want to jump to something from your bio. What drove your pivot from drone parts to materials science?
So it's actually a really funny story. So my co-founder and I were material science nerds, and as you are a nerd, you're in the library quite a bit. I'm sure you've read many research papers. We were the same way, and essentially we were in the laboratory working on advanced materials like carbon nanotubes, graphene, the space elevators of the next generation, and we just really ran into this problem that none of that research was making its way out of the laboratory. And it wasn't until my co-founder was actually reading a book and discovered, hey, there's a material called cellulose and nanocellulose, and it's a wondrous material, 8 times stronger than steel, super strong, all these great properties. And we had no idea about this. So, funny story, what we did is like what I think any great problem solver or engineer would do. You go to the almighty brain, YouTube. We went to YouTube, we typed in, what is nanocellulose? And the first or second video that we saw was a video from a Finnish researcher, so a woman named Mary Lundahl in Finland, and we saw her taking these cellulosic fibers and spinning them into continuous filaments to replace fiberglass and replace carbon fiber. And we were like, that's really cool. So we like, how do we get in contact with this person? No idea how. So my co-founder said, let me just comment on the YouTube video. From a YouTube video comment, she responded to it. We hopped on a Zoom call. And then from the Zoom call, we decided we're going to recreate your research in our garage laboratory at the time. And that was the birth of our pivot into the world of nanocellulose.
So this pivot was driven by social media?
Kind of, I guess you could say, in a way.
That's fantastic. Thank you.
Yeah.
Thank you. Rob, let's shift to you. Talk to us a little bit about Poulterra. What are the problems that you're solving for poultry, and what's the product or platform that you've developed?
Sure. So I think to answer the question, I'll give you a little sense of the scale of the industry. So the U.S. poultry industry is the largest in the world. There's 10 billion birds raised every year. So that would cover Manhattan 12 times, just to give you a sense of scale. So imagine all of those birds going to the bathroom at the same time. So yeah.
We are running the gamut tonight, aren't we?
So today, and for really the last 75 years, which is the age of the commercial poultry industry, getting rid of that waste has been a pretty simple solution. It's just put it on land, use it as a fertilizer, and get rid of it. And that worked well, but we're reaching a point where we've got a lot of populations filling in around poultry facilities. Those poultry facilities have increased 10 times in capacity, many much more than that. And it's becoming just a challenge getting rid of the waste in a good way. And if you think about the poultry industry, it's really centered around the Midwest row crop market, so corn and soybeans, which is the primary food source for chickens and turkeys. That food is railed into the poultry processing facilities to feed the birds, but those nutrients that come with it out of the Midwest get deposited essentially into the poultry acres. And so you're moving and migrating nutrients out of the Midwest where they're used to grow the corn and soybeans into different areas where they can't absorb them anymore. So what we're trying to do is really close the loop on that waste, make it circular, and convert all of that waste into higher value products that condense those nutrients and can ship them back into the Midwest markets where they can be reutilized. So it's an interesting challenge. It hasn't been solved yet. There's really, out of all that waste in the industry today, less than 1% of it's really processed into anything higher value. So that's what we're working on right now.
That's fantastic. Thank you. Zara, you gave us some great overview of the work of LanzaTech in your keynote. From LanzaTech's perspective or from your perspective, and maybe there's not an easy answer here, but what most often breaks when you go from, oh, this works in the lab, to now we're going to do this at commercial scale?
I mean, the question is what doesn't break? I mean, we were talking at the reception earlier. So we basically fill a reactor with liquid that has some trace nutrients. So it's kind of like a watered down Gatorade with no sugar. You put in bacteria and they multiply. We put in about this much bacteria to fill those reactors because it's a self-generating system, so it's great. What we didn't realize was how they would be putting the nutrients in the reactor at some of the commercial plants. So remember, we are working in a steel mill or a refinery, and they didn't so we very carefully packaged the nutrients you're supposed to mix with water. Imagine like a Kool-Aid packet in a size of a 50-pound dog food bag. But it's clean, right? We process it in a very clean facility. And so we get to site and we look, and they have cut open all the bags and dumped them on the ground, and they're shoveling them in with a dirty shovel. And you're like, oh, I didn't account for this.
Yep.
So, I mean, like, you don't know what you don't know. So what you do is you beat the heck out of your system so that it is as robust and resilient as possible. And like, let an intern screw it up and keep track of it, figure out all the ways to kill it, and then record that. I mean, some of the challenges, we have a massive data lake from 20 years of fermentation on gas. And one of the great things that we did as a company was record the failures, because a lot of people don't. You kind of toss that out and you keep the good stuff, but I do think those early failures, when well documented, can save you a lot of time later, because you're going to be looking at a commercial reactor saying, why is it dying? And you're going to remember back to when that one intern, Greg, did something crazy. And so, it's that don't have an oral history is really important, because people come and go, but like, to create an industry from nothing, you need documentation that's searchable. And we live in the age of AI now, so as long as it's down somewhere, it can be searched. But if you never write it down and you have an oral history, I think that's one of the biggest things because everything will break all the time.
And that's a really powerful argument for celebrating your mistakes instead of hiding them and just saying, we're not going to talk about that. Because
create that culture of sharing.
And then write it down for Greg, that intern. Yeah. All right. So Sam, we talked a little bit about Bridges and about, at a high level, what that work is doing. Help us understand how the Bridges initiative is different from a traditional R&D funding program.
So that's a really good question. I think the key thing about most R&D programs that we've all been a part of over the last 2 or 3 decades is that they're typically very focused. They incorporate one sector or another, and they don't really do a good job at painting the whole picture of this process that we've talked about going from R&D in a lab to full commercialization. There are very few grant programs out there that actually fund that type of work. And so what makes Bridges very unique is that it is from front to back. It's the entire ecosystem. So as Neil kind of described in his presentation earlier, it's about use-inspired researchers. So it's about tying industry needs to what academic researchers are actually doing in the lab. So it's research with a customer is what I like to call it. And so you're directly addressing real problems, but it doesn't stop there. We have a commercialization team that are looking at entrepreneurship programs, venture studios, and funding to go from that lab scale to pilot to demo and to help support startup companies. We have a great workforce development and community engagement group that are looking at, okay, what are the educational needs that those industries and these new technologies are going to need in the workplace? How do we build that training into our K-12, into our community colleges, into our tech programs, into our undergraduate programs? And also, how do we train a mid-career worker that might be approaching their 50s and a new plant comes to town? How do they take advantage of that and get that skill set? So we're doing that. We're working on policy, both at the state and federal level. We have policy. And then we have all sorts of side evaluations, so economics, sustainability, all of those things. So it's a really broad, all-encompassing system that if we do it the right way, we should have checked all of the boxes and removed as many hurdles in the process, because it's really about speeding up that innovation. And so having all of those people at the table at the same time help us address factors in real time and address those challenges to make sure that we're meeting the needs of the actual end user of that product very well.
Before you get to, I've got this great product in this whole commercialization process, and then you discover that it isn't generating what your end user needs.
Yeah, a great example. That car panel is a good example of the sheer amount of testing that a product has to go through. And so things like safety and emissions and performance and durability, that component in that car took about 3 years to get through all of that from a manufacturer's perspective. It's very in-depth. I've often joked, and I shouldn't use this joke, but I really like it. I could feed you lignin before I could feed your dog lignin in dog food. So lignin is a great binder, and it's used in pet foods and other things like that, but it has to undergo a stringent safety review, safety protocol. And so a good example is one of our partners in the engine is Underwriters Laboratory. Most of you know that when you buy an appliance or something at the grocery store or at the department store, it's got a little UL tag. We've got those people on the engine to help us think about that safety, the durability, and all of that evaluation that goes into these products. Because again, you don't want to get to the end and say, uh-oh, I've missed that, because that's a deal killer at the end.
All right. So let's explore how these initiatives move from plants in the ground or emissions coming out of some other organization to manufacturing a product that the market wants. And let's start with supply chain, the raw material that you need. So Derek and Rob, you guys are each building businesses that need reliable, scalable feedstock. What's the biggest risk to the supply chain materializing at the volume and the consistency that you actually need to be able to move forward?
I mean, yeah, it's a great question. I mean, like you just brought up, the amount of quality control and testing that has to go through just to get a car door panel part approved takes an immense amount of work. And that's just on the product side. There's still a whole back end side of making sure that the supply chain and the feedstock is reliable. We'll get there. If you say it's going to be there Monday at 9 a.m., it's there Monday at 8:30 to make sure that you're there and you don't hiccup any processes in their manufacturing. And what we're seeing from our side on the quality control is being able to have a reliable feedstock source with small variance in how it changes over time due to weather patterns, due to soil conditions, due to being outside and being in the environment. The way that we started to mitigate that is working with partners that are within the BRIDGES program, working with the teams part of this group, being able to kind of de-risk all of those potential hurdles. And then like you mentioned, there's a lot in today's age with AI and a lot of the more modernization of software where we can take publicly available satellite data and overlay that onto the entire Southeast and see, okay, from 2015 to 2026, what was the soil like? What was the weather patterns? What are some of all of these informations that we can build into a digital, what we call notebook, to make sure nothing gets missed from the QA, QC of feedstock through our QA, QC, through our end customers QA through QC. And I think that's going to be one of the biggest proponents for being able to scale the Miscanthus technologies over these years, is making sure that there's a really good supply chain and people understand that supply chain.
Great. Rob?
Well, for us, the product quality and consistency was really important, but also being able to contract for feedstock on a long-term fixed price basis so that as you're trying to finance a project, you know how much your inputs are going to cost over time. That is a really challenging thing to do in any commodity business. Poultry was really difficult because if you're a poultry farmer, as soon as you clean out your poultry house, you've got to replace that manure, that litter, with fresh bedding. And because of the problems I mentioned earlier, getting access to a wood shavings or sawdust to put in to the house was just not a lot of supply. It was expensive. hard to come by. You couldn't enter into a long-term contract with any poultry grower because they never knew how much it was going to cost to replace it. So what we did, and we came up with something really catchy called manure as a service. So we use miscanthus grass. We plant it on the farm or nearby, and we'll enter into a 10-year contract with a poultry grower where we provide the bedding material every year. Miscanthus is a perennial grass, so that's a real benefit for us. We harvest it every year, give it to the farmer, we clean out their house, take all of the litter, and we use that in an anaerobic digestion process. So it gives us the ability to lock in not only the price and do it on a long-term basis, but we control the quality. We know exactly what bedding is going to be used. We know how old the litter is going to be when we clean out. So it gives us a very consistent feedstock, and we solve that contracting issue at the same time.
All right, fantastic. Zara, you talked about you have to find the right investor, especially from the early stage. What has to be true for an investor to bet on a technology that you're still moving through the pipeline?
That's a loaded question.
Oh, depends on the day of the week. No, I mean, investors are going to want to know if we build a plant, are people going to buy the product, and is it going to make economic sense? So I think the most important thing is that you show you have offtake, you show you have customer, you show you have the market demand. It will change it completely if you show that I am going to sell all of my ethanol into the SAF space in the UK because I can sell it for $9,000 a ton. Because I have such a low carbon intensity that I will beat anything on the market, and I will basically meet all mandates and then some with credits to spare, right? I mean, that's what investors don't. I mean, some of them have teams that understand the technology. They want to know, do you have customers that will be there for 10 years, that will be there until they're paid back? And so on the flip side, that makes us, how cheap can we make the plant so that the payback is shorter so I can get a customer, right? So it's you want your technology, your cost of production to be as low as possible so that when you get paid, everybody gets paid. And your plant is paid off quickly. So I cannot wait to tell you in a few years that, oh, I don't need an investor because my plants make so much money I can make more plants. I'm not there yet. But I mean, that's the dream, right? Someday.
But it sounds like that we'll do like Southern Solutions Part 2.
Yeah.
And you know, we'll
Let's
come
do
back
it.
in X number of years and you'll be, you know, you'll announce that. All right, panelists, as we wrap up. So everybody in the audience is a consumer. Some of the folks in the audience are students. Some folks are in farming and agriculture. Some are investors. Some might be in manufacturing. What is one thing or a useful thing that each of our audience members can do this week as we think about how we support plant-based products?
Ask yourself where your carbon comes from. I mean, or you can even ask yourself where the electricity comes from. That's good for you to all know also. But where is your carbon coming from? Because you have choices, and your choices can turn into decisions made by policymakers. Your choices can turn into companies seeing that a capsule collection they put out actually has strong pull. Like a lot of our consumer goods came out as like, we made 5 shirts. Let's see if people buy them. But now with companies like Athleta, with the outdoor company like Kathmandu, we are their base now. That did not happen overnight. So all their polyester, we are the MEG for everything that they make. We're not even on the tags anymore. We're just there. We are their supply chain. But that didn't happen without people actually on purpose buying the products that were made from recycled carbon. And so ask yourself, if I have $1 to spend, I should think about where that $1's going and what that's supporting.
Yeah, I would completely agree with that. At the end of the day, as much as I would say businesses are run by the votes of your dollars. So on if you're going to be in a situation where you're stuck, and we've heard this called hanger appeal when it comes to the textile space, and it's if you're looking at two different products and one is slightly more expensive than the other, there has to be a really big driver for that hanger appeal. And most consumers are unaware, like you said, where does that electricity come from? From the wall. They're not thinking about the PET plant somewhere that's manufacturing in some region and bringing that to light. So from my side, I would say one thing is just look at the products that you're interacting with. And I think something that's been interesting is most people today are probably aware of the non-stick pan. That was like huge maybe 10, 15 years ago. Everyone's like, we want a non-stick pan, we want a non-stick pan. And then fast forward today, everyone's got rid of their non-stick pans. They're doing a ceramic pan, or they have glass Tupperware instead of plastic Tupperware, because we've become aware of some of the, let's say, harmful things that can come from that. And the reason that happened, the reason those shifts happen and you see more of these products in the market is because you, the consumer, voted with your dollar. That's what actually got these businesses to move. And I think that's one big takeaway I would say.
I think look at where it's made. Plant-based products, waste-to-value products tend to be made more locally and within the U.S. So look for where your product is made, and you'll have a better chance of it being plant-based than not.
So I'm not sure I can add a lot to that, but I'm going to give you a really, really basic thing. And wherever Kankshita is, she should support this, because the easiest thing you can do is the next time you're at a restaurant and they bring you a black or a white styrofoam takeout container, you should ask them why they're using styrofoam. That's the easiest thing you can do, because as Derek said, your dollar votes where they get their products from. And so it's equally as easy for them to get those molded fiber takeout containers that are miscanthus based today in the market. So just asking a question of why are you using styrofoam, or why have you not switched, that's an excellent way to make a difference in a very quick period of time.
Panelists, this has been a fantastic conversation. Thank you guys. Thank you for coming up, for telling us about the work you're doing. Thank you for navigating your way through the valleys of death and the opportunities that lie ahead. Everybody, please help me thank our panelists. So what you've heard tonight, and again, thank you, panelists, thank you so much. What you've heard tonight is a perfect example of how places like HudsonAlpha and how HudsonAlpha, as it relates to Bridges and so many other initiatives, how HudsonAlpha is the organization where discovery meets purpose. We are thrilled by the NSF Engine's award announcement. You've heard us talk about it for years. Major federal support like this validates the world-class science that's happening on our campus. But as recent years have shown us, turning discoveries in genetics into results that matter requires a resilient and diverse foundation of funding. Now, some of you have said, well, some of you have said to me, HudsonAlpha has just gotten this $15 million grant, and there's $150 million, $160 million, so you don't need our financial support anymore, right? Well, let me break that down for you. That's $7.5 million each year for the next 2 years, and the majority of that funding does not go to us. That goes to the work that's being done by the partners. And the funding that does come to us is for specific projects that have very designated tasks and deliverables. It's flexible philanthropic support that actually builds the scaffolding that lets us work on the next Engines initiative, the project that comes after this. And as exciting and thrilling as NSF Engines is, at HudsonAlpha, there are half a dozen other projects of this kind of impact and magnitude waiting for us to be able to land those kinds of large investment dollars. And your philanthropy is what keeps those components going. NSF Engines started 4 years ago. And yes, there was some federal support as a pilot project, but your philanthropic dollars are what kept it going. They're what provided the funding that allowed us to employ the people to continue building out the network and the project and moving that forward. And I can give you any one of a number of examples at the Institute right now that I believe is going to be the next big thing alongside NSF Engines, and every single one of them is being funded, at least in part, through philanthropic funding. So your dollars are critical for us to move the next generation of ideas, to move discovery into purpose. These breakthroughs don't happen overnight. They are built through steady, sustained investments by people who believe in the power of genetics to improve life and to make a difference, the mission of HudsonAlpha. By making a gift to HudsonAlpha's area of greatest need today, you ensure that our scientists always have the resources to push forward the next big discovery. I want to thank you. Many of you in this room are already supporters of the Institute, and we could not do this work without you. You are truly the glue that holds us together. If you'd like to learn more about supporting our area of greatest need giving, you can scan the QR code that's on the screen behind me, or you can talk to any member of our advancement team as you leave tonight on your way out. Now, let me look ahead. We would love to have you join us for part one, well, actually for parts 1, 2, and 3 of our 3-part series on the genetics of healthy aging. I'll be partnering with Kelly East, our Vice President for Educational Outreach. And together, we're going to explore with the audience how biology, lifestyle, and innovation can shape the way that we age. And we're also going to discuss evidence-based strategies towards enhancing health span and vitality at any age. And we're going to have some fun along the way as we do it as well. Registration is now open for part 1, which is September 15th at 5:30 p.m. in the Jackson Center on the HudsonAlpha campus. And I would love to see all of you and your friends and your family members and your neighbors and anybody else that's interested in how we live healthier lives. So with that, let me wrap. Thank you for being with us tonight. Again, thank you to our panelists and our keynote speaker. Let's give them one more round of applause. And with that, let me wish you good night, a pleasant journey home, and I look forward to seeing you again. Thanks, everybody. Have a good night.